Hi guys, this is take 2. Let's see if I can get this done here. We got problems 15 through 17 for cumulative review number 9. Let's go and get started here. We have first number 15, which is given these two functions f and g. We want to find part A, 3 times f of 5 plus g times g of negative 4. And what that means, in case you're not certain, is that we're going to plug 5 into the f function for x, and we're going to get an output. So to start us off here, we're going to go ahead and do exactly what I just said. F of 5 means I am taking the input 5 for x and plugging it into my equation, and I get my output of 13. But then it says 3 times f of 5, so there's a little times here that you can't see because it's so tiny, and we're going to do 3 times 13. And this one part is 39. Now the other part, plus. Now g of negative 4, we need g of negative 4, so my input is negative 4. And notice I'm going to put a parentheses around my input for each time I plug it in. And if I'm using a calculator, I'm going to plug it into my calculator exactly as I see it. If I'm showing my work as I should, I end up getting out negative 4 squared is negative 4 times negative 4, which is a positive 16. 6 times negative 4 is a negative 24. And I end up getting, oh wait, hold on. Mr. Lakin made a little boo-boo. Let's get rid of this. Let's make that a minus. So it's a minus 6 times negative 4. 6 times negative 4 is a negative 24. So we got a minus times a negative, which is a positive, which gets us 40. And then when I add my green and purple number together, I end up with the answer, 79. These numbers are inputs for the function. If there's a number on the outside, take care of that number after you get the output. Let's try part B. Okay, g of f of negative 2. I start inside, so start inside. Start inside and work your way out. So we're going to do f of negative 2 first. F of negative 2, that's our input. Negative 2 is our input, so we'll do 3 parentheses, negative 2 minus 2. And let's do that math. 3 times negative 2 is negative 6 minus 2. Okay, I get a negative 8. So this value is negative 8. Now that means that negative 8 is the input for g. So I got to do g of negative 8. And again, negative 8 is the input for g, so I need negative 8 in parentheses and squared minus 6 times negative 8. Let's see what we get. Negative 8 times negative 8. Negative 8 times negative 8. Negative 8 times negative 8 is a positive 64. Make sure your answer has the right signs. A negative 6 times a negative 8 is a positive 48. And we get 112 here. And that's our answer. We're all done. We don't need to multiply these together because this was an input, which got an output, and then that output is an input for the new function, and that green is our final answer. There is no multiplying. Number 16. Now this problem is a doozy because this problem takes forever. So here's how we do it. Let's take care of our x is greater than negative 1. So I'm going to make a column. I'm going to say when x is greater than negative 1, and on my other side I'm going to get negative 2x squared. Now I'm going to plug in negative 1 here, but I'm going to make a little note that I'm going to have an open circle for whatever number this is. And to show all my work, like Nick Moore likes to do, I'm going to do negative 2 times 1, and I get a negative 2 out. Now I need numbers greater than negative 1, so I'm going to make a little note here. These are for x values that are greater than negative 1. Let's write that somewhere else. X values that are greater than negative 1. Greater than negative 1. So a number greater than negative 1, it could be 0. So let's do 0. When x is 0, I get negative 2 times 0 squared. Notice again, I'm putting parentheses around the number I'm putting in each time. I get negative 2 times 0. I get 0. Let's do another x value greater than negative 1, like 1. So now let's go and plug in 1. Plug in 1, I get negative 2 times 1 squared equals negative 2 times 1 equals negative 2. And let's do 2, just for the heckaronies of it. Negative 2 parentheses 2 squared equals negative 2 times 4 equals negative 8. Okay, now let's make our picture. We got an open circle at negative 1 comma negative 2, so let's make sure we have that open circle here. We got 0, 0, doink. We got 1, negative 2, doink. And we got a 2, negative 8. Whoa, we are way down here. Okay. And let's connect the lines. Let's see here. And okay. And that's the first half. Second half, I'm going to do in green. I'm going to start the entire, oh man, I'm going to start the entire process over again. So now I got 3x minus 1. First of all, I got x is less than or equal to negative 1. I get 3x minus 1. I just got to make a table of values that goes on forever here. In case you're curious, these values are going to be greater or equal. Uh-oh, hold on. Freeze, freeze, freeze. Mr. Lakin, you are so wrong on that. You cannot be more wrong. Okay, let's try that again. So, what we'll get here is we're going to get all x values that are less than, so x's that are less than or equal to negative 1. That's what we're going to get here. So let's take x values that are less than or equal to negative 1. Let's start off with negative 1. And make sure you're showing all that work. We got 3 times negative 1 minus 1 is a negative 3 minus 1. That's a negative 4. Let's do less than negative 1. A number less than negative 1. Negative 2. So negative 2, 3, parentheses, negative 2 minus 1. It's going to be a negative 6 minus 1. That's a negative 7. Let's do another one, negative 3. One common question is, how long do you keep this going for? And I'd say until you run out of space on the graph. So let's start plotting these. Please note, please, 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 please note, we have a closed circle at negative 1 because of the equal sign here. We had an open circle and negative 1 in blue because there was no equal sign underneath the greater than. So the points that I'm going to plot are going to be negative 1, negative 4. So negative 1, negative 4, here's that one, it's closed. And then we have negative 2, negative 7. Negative 7, here we go. And then we have negative 3, negative 10, and we are off the grid. So I shouldn't really do anything else other than that. And I make the line to them, and that's my graph. That is my graph. And you're going to get a point for each of the points that you plot, an open circle at the beginning and closed circle at the end, and that the general graph looks correct. Okay, now f of negative 1. Ooh. So f of negative 1 is tricky, and what we're saying is, even though I plugged negative 1 in twice and got answers out, I'm going to want the f of negative 1 to be closed. So please put a little note here. This is for the closed value. And f of negative 1 was negative 4. F of 2, let's see, f of 2 is, 2 is greater than 1. So I need to use the top equation. So I need to use blue. So actually, let me get rid of this one. So I'm going to use a blue for f of 2. I'm going to use a green for f of negative 5. Because what I'm trying, that's not green. Because what I'm trying to show here is that you don't just get to arbitrarily choose a function. You have to be careful with it. 2 is greater than negative 1, so I need to use the blue equation, because this blue is for all x's that are greater than negative 1. And negative 5 is less than negative 1. So negative 5 has to be plugged into this equation. That's how we kind of figure it out. So let's get the blue first. F of 2 was equal to negative 2 times 2 squared. And you're saying, Mr. Lake, and we already saw this, and I know I'm just having fun. And then we're going to do plus. Now, what's f of negative 5? Well, negative 5 is the input for green. So let's do 3 times negative 5 minus 1, which means it's going to be negative 15 minus 1, which is negative 16. If I add these two numbers together, I get negative 24. Oh. All right, last one. Let's go. That was tough. That's a tough problem. And by the way, I would watch this part again because this is a 10-point problem. And who wants 10 points? I do. I want 10 points. So make sure that you're actually taking the time to watch this video on number, what number is this here? On number 16. So that way you can kind of optimize, you can get as many points as possible for number 16. Because again, it's a 10-point problem. Number 17, hopefully these aren't so bad. Determine if it's a function. This first one is not a function. Not a function. Now, Ms. Logus recommends I read, so let's read the instructions. Determine if it's a function. Not a function. Write yes or no for parts A or B. So, no. If the relation is not a function, explain why. Oh, that's easy. For any x value, for many x values, there are two y values. Y values. And an example is like at 2, x equals 2, I have a point here for a y value, then I also have a point here for a y value, and that's kind of illegal. So for many x values, there are two y values. That's not a function. Then for the last problem, number 17b. Okay, let's see. Do we have a function here? 0 gets 27, 1 gets 22. Yeah, what I've seen some of my students do actually, and I love this, is they actually take the time to write out each one, and then they look at all their x values, and they see, are there any x's that repeat? 0, 1, 2, 3, 4. Nope, this is a function. So, yes, this relation is a function. A function. Now, if the relation is a function, so please make sure you are taking the time to read this. So if the relation is a function, please write a coordinate that you could add to make it not a function. Well, lots of options here. I could do something, so if this is my coordinate, I could do 0, or I could do 1, or I could do 2, or I could do 3, or I could do 4. And in the y-coordinate, any number would be fine. But to make this relation not a function, I would have to put 0, 1, 2, 3, or 4, so that way one of the x's duplicates, and then any number here on this side would make it not a function. And for the sake of argument, for that any number part, let's just put 0. Any number that doesn't duplicate a point. Duplicate. So, for instance, in case that's confusing, 0, 0 would be fine, or 1, 0 would be fine, or 2, 0 would be fine, or 3, 0 would be fine, or 4, 0 would be fine. Any of those would be fine. And that's all, guys. Thanks for watching.